Hi, and welcome back to the Save It for Parts channel, where today I'm trying to figure out what is an oscilloscope and how do I use it. Now, I did a video on this a while back where I got a very simple World War II era oscilloscope, one that only had about 3 functions, and I determined that it's a magic box that makes a wiggly line, and that's still kind of about all I know about the things. When I do a lot of electronics videos on this channel, I often get comments along the lines of, put that on an oscilloscope, just scope that, scope your project. And that kind of doesn't mean anything to me because I don't know how these work. I've been given a number of old vintage oscilloscopes here and I'm interested in using them, but I really don't understand what they're for. They have this kind of intimidating number of knobs and buttons and dials. The basic introductory videos online kind of make things seem even more confusing. The manuals for these assume that you know what you're doing and are also confusing. So I have yet to find a really good introductory look at what do you do with an oscilloscope? Why do you want an oscilloscope? How does it help you with electronics? And how do you get started with one? Now, this video is not really intended to be instructional because I don't know what I'm doing with these and certainly don't know enough to teach anyone else. But if you're a complete newcomer to oscilloscopes like I am, then you could learn right along with me. Now, a lot of introductory oscilloscope manuals will tell you that a scope is basically just a voltmeter that adds a time dimension. We can get an instantaneous voltage measurement from my little selectable power supply, and we can already tell the power supply might not be super accurate because it's supposed to be set to 1.5 volts right now, and it's actually giving me 3.3. So already I've learned something about these cheap little adjustable power supplies. I don't trust these anymore. Now, if we want to see voltage over time, we could also get something like a recording voltmeter. Somebody gave this to me at my recent swap meet, and I have yet to try it. I don't know if it actually works. We might not get too deeply into this thing because that's getting off topic from the video, but yeah, it's a basic little gadget here with this roller of graph paper. Looks like this motor is impacting these little cogs here, so something's bent. This must have been dropped at some point. Okay, I got this thing working, but even at top speed, it's incredibly slow, and it's not really that close to an oscilloscope. I was hoping for more of a up and down kind of... I was hoping we could see the little wiggly line of the voltage change here, but it's not a great example, unfortunately. So let's come back and look at the World War II scope, just as a place to start, because I've played with this before. Now, last time I used this, we just plugged it into the wall outlet, and we got to see the AC sine wave from City Power. And a bunch of people in the comments said, oh, don't do that, you're never supposed to plug an oscilloscope straight into AC. But that was actually the first recommended example in the manual for this thing. And the thing is so old that that's really one of its only functions, is to find out where's the AC voltage and how clean is it. So another gadget that I'd like to try is this thing that I just picked up from Axeman Surplus. I believe this is a function generator or a sine wave generator or something. It's obviously pretty homemade. It looks like it will output a square wave, a triangle wave, or a sine wave. And the little junior scope here does not have the regular B and C connector, which this thing has. I just had to make some probes here basically from a broken multimeter. And this is kind of what you get when you ask how to start using an oscilloscope. If you go online to Q&A forums or electronics forums, people say, oh, just take your scope and start sticking it on stuff and see what happens. And the kind of unstated part there is if the magic blue smoke comes out, you need to spend another $200 on a scope. So I'm going to try not to do that, but I am going to yeah, just stick the probes on things and see what happens, because that seems to be the main way you use a scope, is just exploring your electronics devices. I guess that's a square wave. I have to say, I don't feel like I'm learning anything in particular other than twiddly dials make line go bouncy bouncy. It might be time to give up on the 1946 scope here. I was hoping to use it to kind of verify the magic black box from Axeman and just see, does that do anything? But I can't tell if it's doing anything, so let's move on to another scope. Normally, I think each of these things would cost a few $100s, so I'd really like to thank viewers Brad and Bill for hooking me up with their old ones. I think some of these may or may not fully function, and I don't remember which ones are which anymore, so I'm just going to start down here with the 50 megahertz oscilloscope. Now, in addition to the actual box of the scope, you're supposed to have things like scope probes, and those have their own specifications, like you can have different megahertz, you can have different impedance, you can have different attenuation, none of which I understand. I just have a box here of probes, etc., which I don't even know which ones go to which scopes. I think most of these came with the 500 megahertz scope, but I don't remember anymore. So I'm going to try not to blow anything up. And I do have a little manual for some of the passive probes, which is also all Greek to me. It's talking about the input R, the input C, the division ratio. I don't know what any of this means. And some of these say they're for a TDS 500 or TDS 600 scope only. I don't think any of these are a TDS 500s. This one looks like it might be the most generic. It doesn't say anything specific on the end. There's no fancy box on the end. I'm just going to put that onto channel 1. Now I don't have the probe touching AC, but I do have it kind of near an outlet. So we're just getting, we're basically getting AC interference over radio waves, essentially. We're getting the induced power just through the air, so basically just changing the scale on that sine wave. I guess I'll try it on the Magic Axeman box, and again, hope that I don't blow anything up. That appears to be our 1 megahertz sine wave. Let's see if I can flip this over to triangle. Whoa, okay, I guess that's a triangle. It looks terrible on here, but maybe I can clean that up a little bit. So there's a square wave. Now, it's not completely square, and I've heard that with a new oscilloscope, or at least new to me, and new probe that I haven't used before, I should be trying to calibrate things to see if I can get this more square. And I think there is an internal calibration that I would use over here on the right of the gadgets. All right, I didn't figure out how to calibrate it, but we did get our triangle wave here, which looks a little bit more like a triangle. It's still kind of choppy, but I guess I don't expect much out of a mysterious box that somebody made in their basement. Now again, I'm perfectly aware that I'm just screwing around here and have little to no understanding of what's actually occurring, but this is kind of how I learn the best, by trial and error, by hooking things up, by seeing what settings do what do things look like, how does this jive with what I've learned online or what I've read online, how does this relate to things I've seen in the manual or in other videos, and eventually I start to understand, what am I actually seeing here, what am I doing with this, and at some point some of these things might start to click in my head and I go, oh yeah, that's what I could actually use this for. It's more than just a novelty, it's more than just a mysterious sci-fi squiggly line. I could actually do something with it. I'm not quite there yet though. I'm going to set the 50 megahertz scope aside for the moment and try the 100 megahertz scope. I'm not done with that one necessarily, but I want to see if each one of these actually works. It has a property tag from Naval Station Mayport, Florida, so this still has some like Florida Navy grunge on it. Looking at the back here, this has a lot more inputs. We've got a Z-axis, we've got channel 1 output, we've got A gate, B gate, channel 4 and 5. This has a lot more stuff going on. It also looks like it's been dropped a few times. There are various dents and some parts are broken off. And looking at the front more closely, yes, we have channel 1, 2, 3, channel 4, and channel 5. So that seems like, I think mostly you get like 2 or 4 channel oscilloscopes. So this seems a little more capable of what? I don't know. We've got something here. I just had to push this auto mode. I still can't get this to show anything other than a line. I'm not getting the sine wave anymore. I'm gonna have to go back and watch another couple of videos because I have already forgotten everything that I read and watched online about how to calibrate one of these things. Well, I got it to do something with calibration, but I don't know what. All right, that looks more familiar, although I still haven't quite figured out the hold on this. It's probably not filming this very well because it's just flashing and not really giving me a solid line. Well, that's certainly something. Well, so far everything I thought I understood with the 50 megahertz scope, I now do not understand with the 100 megahertz scope. So I think we're going to set this one aside as well. Maybe we'll move on to the fancier one. You know, we've got a fan running in there. Sounds like either a big fan or maybe even a hard drive. There's definitely something spinning, but I am not seeing any signs of life on the screen or the front panel. And I am hearing some struggling from that fan. There is an intensity dial on the back here, but it's not doing anything with the CRT. Yeah, there's probably something wrong with this. There's probably some bad capacitors, or there's something messed up. So this is probably going to have to be a future project. I'm going to have to put this aside, put it back on the shelf, and at some point we'll have to tear this apart and see if we can figure out what's wrong with it. Let's take a quick look at this frequency counter, which is the other gadget I had up on the shelf there. So this again has a little probe thing here. If we hook it up to that Axeman box running around 4 megahertz, it does read 4 megahertz, although it doesn't seem particularly stable. Or we could try taking a crystal from this vintage crystal-controlled CB radio, These are the receive crystals and the transmit crystals, and that's what controls what frequency it's on. Plug that in down here, turn that over to the crystal setting, and it looks like the base frequency of that particular receive crystal is about 8.8 megahertz. Now it'll be something like in the 28 or 27 megahertz range for CB, but there's probably going to be a multiplier circuit somewhere in there. All right, coming back to the oscilloscopes, let's look at something a little more practical, or at least understandable. Here we are looking at an audio signal. I'm playing some music on my phone, I'm piping it into the oscilloscope, and this is what music looks like. So what does that mean exactly? Well, if I plug an audio cable into the phone, in this case it's a splitter, and yes, I have an old enough phone that it still has one of these antique headphone jacks. Now, this is a standard stereo plug, so it's three conductors. We've got ground and left and right stereo channels, but let's just break that out into a single channel for now with this adapter. And I've got an external speaker, so if we play audio through that rig, we'll just hear it on one channel. Yeah, don't think that cats are going to tip that over now. That's not going anywhere. So how do we visualize that? We are basically just sending out a DC signal. That's the audio here. So if we hook this up to the scope, yes, these are some high quality connections happening here. And I'll go ahead and play that same clip. Yeah, don't think that cats are going to tip that over now. That's not going anywhere. Or we can do some totally copyrighted music and risk demonetizing this video. So we've made a really inconvenient version of Winamp. So now oscilloscopes are starting to make a little more sense to me, at least in the realm of the audio stuff. I'm still not quite sure how I would use this, but if I'm diagnosing a stereo and want to see if there's actual sound coming out, if I can't hear it, well, yeah, I could definitely do that with the scope here. Now, one thing that I've heard is really fun is if you have a scope that can do two channels and combine those channels, you can send in one side of the stereo as X and one side as Y, and you can actually make pictures on the scope. And I've always wanted to try that. My old 1940s scope is far too simple to do anything like that, but I think this one might be fancy enough to handle it. Don't think I have the right probes for this because I cannot get it to become a picture here on that XY mode. Well, I've definitely got something happening, but I am right back to the stage of not really having a clue what's going on. Now, the way this is supposed to work is that one channel is the vertical and the other channel is the horizontal, and if you put them together just right, if you have the right voltage, or in this case the right audio tones, they'll make a picture. Alright, so I got rid of this mess, which I think was maybe introducing some noise into my signal, and there's a practical use for an oscilloscope, trying to figure out how clean a signal is. If I know what the source looks like, then I can see what it looks like at the other end of a cable or something like that. Anyway, I've got a new audio cable with the end snipped off, and now we can see my logo on the screen, although I think, again, the frame rate and the sync rate is going to be different from the scope to the camera, so I don't know if that's going to look like much. So let's try something else. I've got a program on the laptop here called OSCI Render, and that is supposed to give us different shapes and 3D effects that will render out on an oscilloscope. It's just generating an X and Y tone sequence. Now, unfortunately, it's not actually working, and that's because you can hear the tone on the laptop, and it's not getting into the audio cable, because this laptop has not a regular audio jack, but some stupid combo mic audio jack that is not compatible with the standard stereo cable here. Let's try a USB sound card, and of course that doesn't work either. This is a lot of work trying to do anything with these oscilloscopes or get anything useful out of a modern Windows 11 laptop. All right, we're going to try this again. We've got a couple different files here that we can play. There we go. Those actually look pretty good once I've turned up the speed on the render. So the frequency is a little bit higher, so we can actually see some of these shapes a little bit better. So yeah, this is some of the basic clip art that OSCI Render will put out. And you can actually combine all this stuff and you can try to overlay it with something that sounds a little better to the human ear than just... These are just going to be buzzing, so I don't have the audio playing because it'll just sound like annoying buzzing. But you can find all kinds of oscilloscope music on YouTube if you search around. I still don't have this thing dialed in quite right, so things don't quite look the way they do on the preview screen on the OSCI Render software. I was curious if this one would look any better with the visualizations, but I can't actually find an XY mode on it, so I don't think this one will do that. Future Gabe here, I did actually find the XY mode hiding way down at the bottom of this dial, so now I can do some of these graphics. Unfortunately, the scope music files still don't look anything like they do on YouTube. Yeah, the renders look way better on the phone than they do on the actual scope. And we're going to take a final look at this last gadget over here. So this thing is a spectrum monitor, and out of all the equipment here, this is actually designed for satellite use. You can see on the back we've got a 70 megahertz input as well as an L-band input, and we often work with L-band on this channel. And then we can also power an LNB, so this is kind of for diagnosing or setting up a commercial or residential satellite system. But unfortunately for this video, it doesn't work. There's a little light that turns on inside, but the screen does nothing, the controls do nothing, and I can't get it to run. So this will have to be a repair for another day. All right, so I think that is the basic overview of what I have here on the shelf for test equipment and a first look at most of it. So this thing's broken. This thing's broken. The 50 megahertz oscilloscope here is the most approachable for me. This one makes the most sense and it looks the nicest. This Axeman thing was pretty handy. Of course, the antique World War II scope here is fun, but basically completely useless because all it does is show a wiggly line. Frequency counter looks promising. The graphing voltmeter is fun. I might have to play around with that some more in the future. I also have some power supplies further over here, which I didn't really get to, but they're basically just power supplies. Just turn up the voltage and they'll output a certain amount. I think when it comes to test equipment, this thing is still the most understandable for me, and if I'm trying to track down voltage inside of a device, I'm going to reach for this thing before any of this stuff. Maybe when I get around to fixing this one, maybe some of the other ones here will come in handy for repairing that. So, did I learn what an oscilloscope is? Yeah, the basics, I guess. Did I learn how to use it? Again, kind of the basics. Did I learn anything practical that will help me on this channel in the future? That's debatable. I still don't really know how these can help with the channel, so if anybody out there has suggestions for just what can I do with these things, what as a satellite experimenter who works mostly with SDR, can I actually do with these things? Or are there other electronics topics that these will help me learn about? Now, I do have a bunch of electronics test and experimentation stuff, and I'd like to learn more electronics, and maybe these would help me with that along the way. So you will likely see some of this stuff again in the future. I just don't know exactly when or what I'll be doing with it. Thank you again to the viewers who gave me some of this stuff, and I'm looking forward to working with it more. Even the broken ones, I'm looking forward to trying to fix those. And finally, thank you to everyone out there for watching, and we'll see you next time.